Alright, we're going to take a look at equal matrices, and we're basically going to be determining how we know when matrices are equal and when they're not. Well, the first thing is just to look and see if there's an equal sign there. And so if I'm looking at some examples of what are equal matrices, well, first of all, the dimensions have to match, right? So I'm going to put on here dimensions must match, right, for the matrices to be equal, okay? And then the other after that, the entries, that just means these right here, these things right here, those are entries. Just that's right there, that's an entry, that's an entry. The entries corresponding in the same location, right, in each matrix, corresponding entries must be equal. Alright, so let's take a look at this first one. What I have here is 2 rows, 1 column, right? So this is a 2 by 1. So this is a 2 by 1. This is also 2 rows, and then 1 column, and that's also a 2 by 1. And so if a 2 by 1 is equal to a 2 by 1, we look, of course, there is an equal sign there, so those have to be equal. Same thing here. This entry must be equal with the corresponding entry over here, which would be the W. So W is 1, X is 2, Y is 3, and Z is 4. So that's real simple. It doesn't have to be that the numbers are equal. We can have variables, right, that we set equal to numbers, and then that lets us know the value of the variable. Let's take a look at examples that are where they're not equal. Well, that would be an example right here. This is a 3 by 1. This one is a 1 by 3. And we cannot set those equal, so I've put not equal to because they're not equal. I don't have corresponding dimensions. I don't have matching dimensions. So the next thing would be, okay, well, I have a 2 by 2 here. I also have a 2 by 2 here, but I can't say that those are equal, right? So I mean I can't put them put an equal sign there because what? 5 is not equal to 4. 2 is not equal to 3, right? 3 is not equal to 2. So there's basically what you need to know about equal and unequal matrices. Now, what if they do say that they're equal? Then we're assuming they've gone, complied by the guidelines, and then we can do things like, what do the directions say here? Determine the values of the variables that make the matrix equation true. So here's what I know. This is a 2 by 1. This is also a 2 by 1. And I'm going to take what's inside there. I'm going to set each of the positions equal to the other, right? Each position is equal to its corresponding position. This is equal to this, so I'm going to make it an equation. And then I'm going to have 2x plus y is also equal to that one. Now, you look at that and you go, well, shoot, that's just a system of equations in 2 variables, so I could solve that any way I want. And I'm looking at that thinking, hey, the fastest way to do that is with elimination. So I have 3x is equal to 9, I have x is equal to 3, and then I substitute back. X minus 3 is 2, and that makes x a 5. Right? Okay, so we have, excuse me. That's supposed to be, excuse me, let me put the 3 minus y. There was a problem, wasn't there? So I'm going to have y is 1. I thought it was a 1. Okay, so I have 3 and 1 is my answer, right, for that. Okay, so there are a couple of examples of matrices being equal, the things you need to know about it. Thanks for watching.